So far we've talked about revolving around the x-axis or the y-axis. But what we find is you can revolve around really any line, more specifically any horizontal or any vertical line. And we're going to talk about doing that now. And it's a little counterintuitive because it's kind of easy to think of functions being, distant from the standard coordinate axes, but it's a little more difficult to think about, okay, what does it mean to revolve around y equals 5? And if you really think about it, if I had some sort of function and I had, if I had a line that was right here and I revolved, well, here, if I have a pole and I revolve a little bit around it, if I move the pole up, the function has to go a lot further, or if I move it down, it has to go a lot further. And so you have to think that as that axis of revolution gets further away, it's kind of like taffy. It just stretches and swings, so you're going to get larger volumes. But anyway, you find that it's just revolving around a different axis than the standard coordinate ones. And the way we do this is actually pretty much the same way that we do any of these functions. It's not really different. It just looks different in the beginning. So in this case, I have two functions. I have sine of x and cosine of x. So sine of x is doing this. I probably should have written these in different colors. Cosine of x is doing this. Hopefully you kind of recognize sine and cosine. This is a pretty terrible cosine. See how that... Anyway, but there's this orange region, and we want to revolve it around the line y equals 5. So what we're going to find is I want to take this thing and I want to spin it all the way up here. So I want to take it and slap it and just swing it all the way around. But this challenges our notions of what we normally expect. If we were doing this around the x-axis, for instance, we would say, okay, well, the outer function is this sine function because it's further away from the x-axis. And the inner function would be the cosine function because it's closer to the x-axis. Pretty simple. You'd actually have, you'd have some interesting challenges as you went there. But anyway, that's simple, straightforward. You say, oh, here's my inner and my outer. But when we're doing it with an arbitrary line, what you have to do is you have to find that distance from the line, not from the axis, from the line. So you say, okay, if I start at this line, which one gets me closer? Okay, well, if I go down, boom. I'm always closer to the sine function. I'm always closer to the sine function in this revolution. And I'm always further away from the cosine function. So since the cosine function is further away, that means if I revolve that, I'm going to get the larger volume. Similarly, if I take that closer function, when I revolve it, I'm going to get a smaller volume. So I always want to subtract the smaller volume from the larger volume. As a result, what you're going to do is you've got to figure out, okay, how do I define some sort of, really it's a consistent radius function here, but whatever. So we're going to say, okay, well, what's the distance? Normally we say, okay, what's the distance from the x-axis? Okay, well, that's simple. It's just whatever the function value is, because that's, if it's 0, it's on the x-axis. If it's 5, it's 5 above the x-axis. That's the distance. In this particular case, you have to say, okay, what's the distance from the line to the height of the function? Well, that's just going to be 5 minus the height of the function. It's the distance from the line to the function. The distance from the line to the function. So in that case, it's 5 minus f of x. Now, in this case, the one that was closer, we're calling g of x. The one that's further away, we call f of x. So let's figure out a systematic way to do this. We say, okay, if I want to revolve around some line y equals c, so instead of saying y equals 5, let's talk about an arbitrary line. So we have to find the function that's closer to c. We're going to call that g of x. So no matter, usually you're not given g of x. You might be, but usually you're given it's cosine of x or x plus 2 or whatever, some line. Then you look at this one and say, all right, what's the further one away? Okay, we're going to call that f of x. Then what you do is you use this sort of definition. You use the distance that those functions are away from the revolving line. C minus f of x squared. Or, I'm sorry, c minus f of x. That's the distance you are from c. C minus g of x. That's that radius from c. And then we perform that that volumetric difference just like we always have. It's just the same. We have pi. Instead of f squared minus g squared, you have this c minus f squared. C minus g squared. That's it. That's the only difference. And in fact, there's an even more interesting thing. If we just thought about this as the x-axis, right? So the x-axis is here. If we moved the x-axis here, it would be similar. It would be similar to saying that this is like cosine of x minus 5, and that's sine of x minus 5, right? Well, then what you do is you would say, well, what's the function height? Well, it's this. What's the function height? Well, it's that. Okay. Well, when you square cosine of x minus 5, it's the same thing as 5 minus cosine x squared, right? Because the squared, multiply it out, you'll see that it is. It's the same idea. You don't have to overthink it. But the formula states that you're supposed to write it like this. So you take the line that you're revolving around, you subtract the function. The line you're revolving around, subtract the function, square them, go at it. In this particular case, when we run it through, we have pi over 4 and 5 pi over 4. Now, that comes from the fact that hopefully you know your unit circle well enough to know that that sine and cosine are equal to each other exactly twice in the unit circle. One at pi over 4, one at 5 pi over 4. That's it. Those are the only two times in the unit circle. So pi over 4, 5 pi over 4. That tells me those are the ranges. I know the inner radius here is that sine function, so the inner function is the sine function, so that's wrong, right? That tells me that, my outer radius is actually cosine. So this is wrong, right? I'm going to get do. So I get negative sine squared plus cosine squared plus minus. All over that. So you end up, when you multiply it out, you get all this here, which is, we're not going to solve this. The reason being is that you would need to use some trigonometric identities to shore that up. And we're not really there yet with our integration techniques. And these are fairly straightforward, but it's a little more complicated than what we're trying to do. So anyway, I'm all over the world here. What I'm really trying to get at is that it's just about the distances from the line, man. Like, don't overthink this. This is a very commonly overthought, problematic thing for students. They mess it up all the time, but it's all about which one's closer to that line, which one's further away from that line. Subtract it. That's it. Please don't overthink this.